Earthquakes, unfortunately, can't be predicted, but thanks to the progress made by geology in recent decades, we can at least try to identify regions where the ideal conditions for their occurrence exist. We know that the Earth's crust is made up of a composite of so-called tectonic plates, large portions of crust, and to a small extent also the upper mantle, that continuously move alongside each other, like pieces of a giant puzzle. In addition to the 20 main plates, there are also so-called microplates, which are smaller in size. Well, the regions where tectonic plates come into contact with each other are the so-called subduction zones, where the smaller or less energetic plate tries to escape the collision by diving beneath the larger one. Many of the plates affected by these faults, Chile and Japan for example, are sadly known precisely for the devastating earthquakes that have struck them in the past, while another region, California, crossed by the San Andreas Fault, is often said to potentially suffer the consequences of a fearsome earthquake in the future. The big one, as they call it around there. Nothing compared to what could soon unleash in a stretch of coastline located just a bit north, the one dominated by the Cascade Range. Forget the big one, it'll be a big one cubed, something the locals have already dubbed, with shameless pride, the really big one. It's true, all over the world, not just in America, people always talk about the San Andreas Fault and the big earthquake that could wreak havoc in California at any moment. Yet a recent and well-documented study explains that there's a place talked about much less, which in the near future will certainly be devastated by a much more serious earthquake. Not for nothing in recent decades, much of the research on tsunamis and earthquakes has focused on a very specific place, the coast of the northwestern Pacific, where increasing evidence indicates that recurrent episodes of earthquakes followed by even more destructive tsunamis have occurred in the past. The source of those disasters, now distant in time, has been identified not long ago in the Cascadia subduction zone, in a fault that lies about 200 kilometers off the coast and extends for about 1,100 kilometers from Cape Mendocino in Northern California to Vancouver Island, Canada. Cascadia, whose Spanish name refers to the volcanic mountain range of the Cascades, extends inland and parallel to the coast for a length similar to that of the fault. And this entire region is now believed to be capable of producing earthquakes of magnitude 8 or 9, as devastating as or more than those unleashed off of Indonesia in 2004 and Japan in 2011. The Cascadia subduction zone is where the tectonic plates called Juan de Fuca and Gorda are colliding with the North American plate and slipping beneath it. The plates move slowly but steadily towards each other, but they are currently locked in the areas where they are in contact. Eventually, however, the moment will come when the energy accumulated in the collision will exceed that generated by friction, and what will probably be defined as the greatest natural disaster in the history of North America will occur. Terrible, but how can we be sure of all this? And why is there so little talk about this future catastrophe? Well, there are many reasons, ranging from the media conditioning of the many Hollywood versions of the ultimate cataclysm, namely the one that destroys the iconic city of Los Angeles, to the cultural isolation of wild regions like Oregon and the Canadian border. To answer the first question, before the mid-1980s, it was thought that the danger of tsunamis on the northwestern Pacific coast could only come from tsunamis triggered by distant earthquakes, which would arrive with hours of warning. The possibility of local tsunamis at the time raised little concern. This was mainly due to the fact that there were no written records of such events, and it was believed that the Cascadia subduction zone was not capable of producing large earthquakes. Until 40 years ago, it was not even known that the Cascadia subduction zone existed. The last major earthquake in that area had occurred several hundred years earlier, when the Pacific coast was not yet colonized by Europeans. Those lands were occupied by Native Americans who, having never used writing, did not leave a written record of that earthquake. Without traces and clear evidence of a previous cataclysm, and indeed nature quickly heals its wounds, the settlers saw the value of that area, fertile, temperate, and seemingly benign, and appropriated it without realizing its danger. A century and a half passed before anyone had a hint that the northeastern Pacific was not a tranquil place, but only a place going through a long period of quiet. And it took another 50 years to discover and interpret the seismic history of the region. The first clue came from geography. Almost all of the world's most powerful earthquakes occur in the Ring of Fire, the volcanically and seismically unstable belt of the Pacific that stretches from New Zealand through Indonesia and Japan, across the ocean to Alaska, and along the western coast of the Americas to Chile. Let's remember together the mournful chain of the last 60 years. Japan, 2011, magnitude 9.0. Indonesia, 2004, magnitude 9.1. Alaska, 1964, magnitude 9.2. Chile, 1960, magnitude 9.5. It was only in the late 1960s, with the advent of plate tectonic theory, that geologists were able to explain this trend. The Ring of Fire, it was discovered, is actually a ring of subduction zones. Before moving on, don't forget to subscribe to our channel if you haven't already. Make sure to hit the notification bell so you don't miss out on our daily videos. Most earthquakes in the region are caused by continental plates that remain locked against oceanic plates, like North America is locked against Juan de Fuca, and then suddenly unlock. Almost all volcanoes are formed by the sliding of oceanic plates beneath continental ones, which eventually reach temperatures and pressures so extreme that they melt the rock above them. Apparently, only the northwestern part of the ring showed no signs of past or present seismic activity. Was there a gap in the Ring of Fire then? The smoking gun for the solution to the case eventually came from Japan, where many documents from that period were discovered, talking about a massive wave that devastated the coast. That wave was clearly a tsunami, but its origin was unknown, so much so that it was defined in ancient chronicles as the orphan tsunami, that is, without a cause. Several years later, in 1996, it was demonstrated that the tsunami was caused by an earthquake of magnitude 9.0 that occurred in North America on January 26, 1700. Thanks to this evidence, it was discovered that some Native American tribes had also maintained and passed down the memory of that event. Stories were referring to the shaking of the earth or to immense waves from the ocean. They were believed to be legends, but they were actually accounts. And from the written Japanese sources, together with the unwritten ones of the Native Americans, we now know with reasonable certainty that at 9 p.m. on January 26, 1700, along the western coast of North America, one of the greatest earthquakes the world had ever witnessed occurred. The Cascadia submarine fault disintegrated along its entire length, producing tremendous tremors, with huge tsunamis sweeping across the Pacific to Southeast Asia. The recognition of definitive evidence in geological documentation tells us that it was not a unique event, but a disaster that has repeated many times at irregular intervals of hundreds of years. Geological evidence indicates that at least 41 major earthquakes have occurred in Cascadia in the last 10,000 years. How do we know? Well, when a strong earthquake occurs in open water, the upheaval causes mud and sand to begin to flow along continental margins and into submarine canyons. In the abyssal plain, coarse sediments called turbidites flow. These sediments are clearly distinguished from the fine particulate matter that accumulates regularly between major tectonic events. Dating the fine particles through carbon-14 analysis and other methods allows us to estimate with great precision when major earthquakes occurred in the last 10,000 years. Dividing 10,000 by 41 gives 241, which is the recurrence interval of Cascadia, the average number of years that passes from one earthquake to another. This period is dangerous for two reasons. It is long enough to build an entire civilization on the worst fault line of a continent, and also because it is not long enough to worry about it. It has been 315 years since the last event of a cycle that has an average recurrence of 241 years. Of course, recurrence intervals are based on average values, and 10 can be the average of 9 and 11, but also of 2 and 18. But recently, geologists have predicted a 37% chance of an 8.2 magnitude event occurring within 50 years, and a 10 to 15% chance that the entire Cascadia subduction zone could collapse with a magnitude 9.2 event within the same time frame. There will come a time when the compressive movements of the plates become impossible to sustain statistically, and it will be at that moment that the North American plate will bounce like a spring. After that, we can only imagine what will happen. An earthquake of magnitude greater than 9 will shake the entire Pacific belt across the subsidence zone. Seismic waves will arrive on the coast first, with a magnitude between 7 and 8. The entire northwestern edge of the continent from California to Canada will sink by at least 2 meters and move from 30 to 30 meters westward. The severe shaking will crumble older buildings, collapse bridges, cause landslides, and trigger the so-called liquefaction of the soil, a phenomenon whereby solid ground becomes almost liquid, destroying everything above it. Part of this displacement will occur below sea level, which will move a colossal amount of water. The ensuing surface wave will rise, forming a large hill, then collapse. One side will rush westward towards Japan. The other will head eastward in a liquid wall stretching 1,000 kilometers that will reach the northwest coast, on average 15 minutes after the start of the earthquake, giving people very little time to escape to higher ground. The incoming waves could be as high as 9 to 12 meters, but some models suggest they could reach up to 30 meters and in many parts of the coast extend up to 20 kilometers inland. In the Northeast Pacific, the impact area covers approximately 330,000 square kilometers, an area that is home to major cities like Seattle, Tacoma, Portland, Eugene, Salem, the capital of Oregon, Olympia, the capital of Washington State, and where currently about 7 million people live. When the next major rupture occurs, that region will experience the worst natural disaster in North American history, outside of the 2010 Haiti earthquake, which caused the deaths of over 100,000 people. In comparison, about 3,000 people died in the 1906 San Francisco earthquake. About 2,000 died due to Hurricane Katrina and almost 300 in 2012 due to Hurricane Sandy. The grim forecasts of the really big one in Cascadia suggest instead that the earthquake and tsunami will kill about 20,000 people, injure 40,000, and displace at least 2 million evacuees for several months. These numbers might seem almost comforting compared to the carnage wrought by earthquakes in much more densely populated areas of the world. So one might ask, are we then at the mercy of these events without being able to do anything to counter them? When 40 years ago it became clear that sooner or later we would have to deal with the awakening of the Cascadia Fault, we were far from having an idea of how much could be done to cushion the impact of the tsunami. The inertia persisted until 2004, when the tsunami that hit Sumatra convinced local and U.S. government authorities to implement a sophisticated defense system based on real-time satellite detection of even the slightest changes in sea level. For the coasts of the United States and Canada, Alert Center scientists are now generally able to issue the first warning messages within 5 minutes of an earthquake, thus ensuring in the case of the Cascadia Fault, a warning for the population of about 25 minutes. Not much, but let's not forget that we are not talking about just any catastrophic event, but the really big one.